In this video, we're going to start talking about quadratic functions and their graphs. So thinking about a quadratic function, remember a quadratic function is a second degree polynomial, so that means it has an x squared value in it. And a, b, and c, in this case, ax squared plus bx plus c, a, b, and c are just real numbers, but a can't be 0. If a was 0, then we'd end up with a line, not a parabola. Okay? So, thinking about characteristics, here are two parabolas, okay? One facing up, one facing down. And characteristics of our quadratic function is that if a is greater than 0, your quadratic, the graph is going to open up. Your quadratic function or parabola is going to open up. Whereas if a is less than 0, it's going to open down. And that's, this is considered opening up, this is considered opening down. Okay? Your vertex is always either the highest or the lowest point of your parabola. In this case here, it's this very bottom point. In this case here, it's this very upper point. So your vertex, if it opens up, is going to be a minimum point. And if it opens down like this, it's going to be a maximum point, meaning the largest or highest point. Okay. Your axis of symmetry for a parabola is this line here that cuts right down through the vertex. And it's considered an axis of symmetry, meaning if you were to fold your graph on that point, these two sides of the parabola would lay on top of each other. Okay. And your axis of symmetry, it's a line, but it's one of those special kinds of lines that you learned about earlier in algebra, where it's going to be x equals some number. Okay? It's a special kind of line where it's x equals some number. Okay? And then we also talk about x-intercepts and y-intercepts. So your x-intercepts are where it crosses your x-axis, here and here for this parabola, here and here for this parabola. And so they are always going to be of the points of the form some number, comma 0, meaning if you put in 0 for y, you would get those points. We talked about our discriminant being our last section, being how you can tell how many solutions they have. These both would have two solutions. Remember, you could also have cases where there is only one solution or no real solutions. And in the same instances, if you looked at the discriminant, this would have two x-intercepts. You could also have one x-intercept or no x-intercept. The y-intercept is where it crosses the y-axis. And your parabolas will only ever cross the y-axis once. And that is where you put in 0 for x and comma some number. And so that's, you will only ever have one for your y-intercepts, but it's important to remember that you could have 2, 1, or none for your x-intercepts. Okay? So some things to think about your parabolas. They're your quadratic functions. Okay? So let's just go ahead and graph this quadratic function, see what we come up with. We're going to make a table of values because up until this point, that's the only way we've been able to graph. And I got it started here for us. Remember, when we're plugging in the values for x. So a negative 2 squared, minus 2 times negative 2, this is my quadratic function I'm using, and then minus 3. So this becomes 4 plus another 4, so that's 8. 8 minus 3 is 5. So we're going to graph the point negative 2, comma 5. 1, 2, 3, 4, 5, and that looks like this. The next one, when I plug in negative 1, so this becomes positive 1 plus 2 is positive 3, and then minus 3, so we're at 0, so negative 1, 0, looks like this. And at 0, I have 0 squared minus 2 times 0 minus 3. So 0 minus 3 is more down here at negative 3. It's kind of hard to write. I guess that's a little bit smaller of a box than I had anticipated. So my answer here is negative 3. So negative 1, negative 2, negative 3. At 1, I'm going to have 1 squared minus 2 times 1 minus 3. So this becomes 1 minus 2, so we're at negative 1, minus 3, we're at negative 4. So that looks like this. And then at 2, 2 squared is 4 minus 2 times 2. So that becomes also 4. 4 minus 4 is 0 minus 3. So now we're at negative 3 again. Notice my parabola has started to turn around. A parabola will always be symmetrical because of that vertex. Remember, axis of symmetry goes through the vertex. So then I could continue this parabola back up. So if I go, my next point would be here at 3, 0, and my other next point would be here at 4, 5. So if I pretend that I can draw it neatly, my parabola looks like this. Okay, and it's symmetrical. So when you are graphing your quadratic equations, or functions, some things I might ask you are, where is the vertex? And you could say the vertex is at this low point here, which is 1, negative 4. What are your x-intercepts? Well, my x-intercept, I have one here at negative 1, 0, and one over here at positive 3, 0. What about your y-intercept? Well, that's the point 0, negative 3. And if you wanted to draw in your axis of symmetry, it would be, you always use a dotted line because it's not part of your actual graph, but you would draw it in just like that. Okay, so that gets us started with section 10.4. I'll see you in the next video.